This week at NASA. Astronaut Scott Kelly has been selected by NASA to begin a one-year mission aboard the International Space Station in 2015. Joining Kelly on the ISS will be Russian cosmonaut Mikhail Konyenko. The pair will launch aboard a Russian Soyuz spacecraft from the Baikonur Cosmodrome in Kazakhstan in spring 2015. Their 12-month stay aboard the world's only laboratory in microgravity will provide new data about how the human body reacts and adapts to the harsh environment of space. That information will help scientists assess crew performance and health and develop better ways to reduce the risks of long-duration spaceflight, as NASA plans to send the next generation of explorers on missions around the Moon, to an asteroid, and ultimately Mars. The next crew headed for the ISS on Expedition 3435 continues to train in Russia for their missions. NASA's Tom Marshburn, the Canadian Space Agency's Chris Hadfield, and Russian cosmonaut Roman Romanenko are scheduled to launch to the station on December 19th, where they'll become the second half of the Expedition 34 crew. They'll be joined on Expedition 35 next March by NASA's Chris Cassidy and cosmonauts Pavel Vinogradov and Alexander Mazurkin. Scientists with NASA's Messenger mission say new observations made by the spacecraft confirm a long-held theory that the polar regions of Mercury harbor an abundance of water ice and other frozen volatiles.
Messenger has revealed a very important chapter in the story of how water ice and other volatile materials have been delivered to the inner planets. It's extraordinary that this chapter is so well preserved on the planet closest to the Sun.
Given its proximity to the Sun, Mercury would seem to be an unlikely place to find water ice. But since the tilt of the planet's rotational axis is almost zero, scientists suggested decades ago that there might be water ice and other frozen volatiles trapped at Mercury's poles, which never see sunlight. Messenger, which stands for Mercury Surface Space Environment Geochemistry and Ranging, is the first spacecraft to orbit the solar system's innermost planet. NASA Administrator Charlie Bolden toured the United Launch Alliance's Space Rocket Production Facility in Decatur, Alabama. The facility is home to two families of rockets, Atlas and Delta. Together, Atlas and Delta rockets have had more than 850 successful launches. Their major fabrication, assembly, and integration are completed at the Decatur facility. ULA is a joint venture of Lockheed Martin and the Boeing Company. A J2X power pack assembly burns brightly during the latest hot fire test conducted at the Stennis Space Center. Lasting 278 seconds, the test used newly installed gauges to measure how much strain the turboprop placed on the engine's turbine structure as it spun at various high speeds. The test was the latest in a series used by engineers to evaluate the J2X, which will help power the upper stage of NASA's new Space Launch System. And they're getting ready for the SLS at the Kennedy Space Center. This time-lapse video shows Crawler Transporter 2, fresh from the first phase of a major overhaul, taking a test drive from Pad 39A to the Vehicle Assembly Building. Kennedy's two Crawler transporters have moved mobile launchers and their mounted vehicles from the VAB to KSC's Oceanside launch pads since the Apollo era. But with the Space Launch System in development, engineers began modifying Crawler Transporter 2 last December to ensure it can handle the agency's heaviest rocket ever and help move America's human spaceflight program onward and upward for years to come.
Hi, my name is Torsten Zorn. I'm Tactical Downlink Lead on the Mars Science Laboratory, and I'm coming to you with your Curiosity rover report. Since November 10th, we've been tracking a very large dust storm on Mars with Mars Reconnaissance Orbiter, Curiosity, and Opportunity. Luckily, this dust storm has abated, and even if it didn't, it would have been fine for Curiosity. It's well within its design limitations. Recently, Curiosity was able to take a beautiful high-res image of herself using the MAHLI handheld imager. By putting together a sequence of very complex arm motions, we were able to take dozens of images and splice them together, creating a beautiful self-portrait. After several weeks of being stationary at the Rocknest site, we began driving again on SAW 100. This marked a significant milestone on the mission as we reached about a half a kilometer of total driving distance on the surface of Mars. Currently, the left front wheel is sitting on a rock that we've dubbed Bell Island. We plan to back up off that rock to bring the rock into the ARMS workspace, and we're going to do some contact science on it with APXS and MOLLE. After completing our science campaign at our current location, we're going to be moving to the east to a place called Point Lake. From here, we're going to be looking for a target to perform our first ever drill on Mars. This has been your Curiosity Rover Report. Check back for further updates.
Chief Technologist Mason Peck was a keynote speaker at the NASA Innovative Advanced Concepts Program's 2012 Fall Symposium. Held near the Langley Research Center, the NIAC event included panel discussions on topics ranging from propulsion and power and space debris removal to near-Earth object mitigation and robotics and space probes.
It's important for us at NASA. It's important for us as a nation. And it's not only about investing in technology for the sake of science, for the sake of human space. It's also done because it advances our economy. It means we can design new computers, new smartphones, new applications, new medical applications, new things that will change our lives here.
Though the effect of Hurricane Sandy is undeniable, the impact of the storm to Wallops Flight Facility was minimized thanks to an improvised beach and seawall project that proved critical to the protection of Wallops launch assets.
You would have had sand inundation probably into their liquid fueling facility area, which is all stone now, which would have been quite a big mess to pick up. It could have been pretty catastrophic for that operation, for the Antares operation possibly.
But the protection of the beach and berm improvement known as the Wallops Island Shoreline Protection Project came at a cost. It is estimated that some 500 to 700 feet of berm was wiped out by the superstorm. But Wallops engineers have a plan in place to deal with this temporary situation.
It's like a brake pad. Over time, that brake pad starts wearing down. When it gets to the point where we need to re-nourishment, we're going to basically twice a year, we're going to look at this beach, survey it, and find out where the beach is, what it's doing. And we expect on a 3 to 7 year cycle, we'll have to re-nourish this beach.
Each re-nourishment project is expected to include about 800,000 cubic yards of sand. In the meantime, NASA officials are working to address immediate needs of the beach following Hurricane Sandy.
I'm Cody Ensley, and I do software engineering on Robonaut at Johnson Space Center. Basically, the robot, Robonaut 2, behind me, has onboard software. The processors actually live in his stomach. What I'm doing is helping to architect the software that will allow the robot to be able to move around inside the space station autonomously. I was born and raised on the Flathead Indian Reservation in Pablo, Montana, and when I was a kid, growing up, my parents invested a lot of money into Legos, and I think that that's probably the reason that I ended up here today. I was not one of those kids at the age of 6 who knew they would end up with NASA. One of NASA's own, Scott Askew, was involved in a program called the NAFP, which is basically where NASA lends out professors to tribal universities. I heard about something called the Undergraduate Student Research Project, and I applied for the USRP program. After successive internships and then finally a co-op, I was hired here at Johnson Space Center. Being able to do outreach and show that there are opportunities like internships, co-ops, where not only you can leave to get training, but you can bring that back to the reservation and you can help pass that along to other people there, has probably been my proudest personal accomplishment. We don't want robots to replace people. We don't think they can, but we definitely think that we can assist people in getting to the next frontier faster.
19 years ago, on December 2, 1993, the first Hubble Space Telescope servicing mission, STS-61, got underway with the launch of Space Shuttle Endeavour and her 7-member crew from the Kennedy Space Center. A corrective optics package designed to fix a flaw in the telescope's primary mirror was successfully installed, sharpening Hubble's vision from blurry to pristine. Hubble also received instrument upgrades and new solar arrays during the course of 5 spacewalks. And 5 years later, On December 4th, 1998, Endeavour began another mission, this time as the first shuttle assembly flight to the International Space Station. STS-88 delivered to the station the first American module, Unity, which was mated to Zarya, the Russian functional cargo block module launched to orbit 1 month earlier. The crew completed 3 spacewalks to connect power and data cables between the modules. And that's This Week at NASA. For more on these and other stories, or to follow us on Facebook, Twitter, and other social media, log on to www.nasa.gov.